Anyone's still writing? Looks like everyone's done. Okay. So now we're going to look at the different types of systems. Okay, so you have the consistent, inconsistent, and dependent. Oh, dependent equations or systems. Okay, so to kind of get a visual for each one, we'll start off with the consistent. And those have at least one solution. Okay. Now it may have more than one, but it has at least one. So if you want to look at that as far as a graph, let's say if we have just two random functions, both on the same graph. Let's say you have this function and this function. And we'll call this our f of x and this our g of x. Instead of f, let's say function 1 and function 2. Function 1, function number 2. Right there would be your solution. So wherever those two lines cross, that's where x and y are exactly the same. So that would be your solution. Okay, so you know you have that one common point, which is what we solved before. Now, inconsistent do not have any solutions at all. Okay, which means that if you think about it, they're parallel to each other. Let's clean that up a little bit. Now, if we drew a graph of that one, exactly. Okay, so if we have our x and y axis, so if you have a function here, the only way it will never intersect is if that one has the exact same slope. Should clean that up some. Which means at no point will they ever cross. You can kind of think of them as like railroad tracks. They're always just right next to each other. Okay. Now, dependent systems just kind of overlap each other. That means any solution for one will always be a solution for the other. So kind of just stacking them on top of each other.
Oh, it's still the same equation.
Yep, the same equation, but one may be, every term may be multiplied by 2 or something like that. It's the exact same graph, just a little bit different as far as how they're calculated.
Okay.
If you manipulate one, you'll get the other. Okay, so now we have our dependent.
So is it where they have, do they have a different slope?
Nope, they have the same slope, they have the same intercept, they have the same everything.
Okay.
It's just, they tweak it a little bit to look a little bit different.
Okay.
But I'll give you examples of each other. Have identical solutions. Oh, straighten that up. Now with this one, the graph is a little hard to, I guess you can say, explain unless you see it drawn out. Okay, so let's say this is one function there. The second, I mean, not one function, one equation. The second equation may be, every term may be multiplied by 2. So it would go really right on top of it, but it's just longer.
Oh.
But since this one goes on forever, and the one that's longer goes on forever, they're just on top of each other. So the second one would really just be a longer version of the first one, or a shorter version if you divided each term. Now, the one thing you have to remember is, well, not one thing, but one additional thing you want to remember is that when you have a dependent system, it's also consistent. Because remember, consistent just means you have at least one. This one has at least one solution. So if you have at least one solution, any dependent system is also consistent. So we'll make a little side note of that. Move that up a little bit. So dependent systems are also consistent systems. Remember, that's because it has at least one solution. Okay, so any questions on that one? All right, so this is how you would be able to identify them if you saw them drawn out in a graph. If you have the equation, that's a little bit different story. I'll show you how to solve for which one you need in an equation. Well, when you have just the equation. Oh, I'm still writing. Okay, leave that up for a few more seconds. Okay, so what if you wanted to solve the system? Oops, straighten that up. So 1/2 times x minus y equals 3. And x equals 6 plus 2y. Okay, so here you already have x equals 6 plus 2y. So all you have to do is replace x in the first equation. So since x is equal to 6 plus 2y, so you just replace x in the first equation. Okay, so we have 1/2. I'll say 1/2 x minus y equals 3 becomes 1/2 6 plus 2y. Minus y equals 3. And then here we just solve for y. Okay, so if we distribute our 1/2, 1/2 times 6 is equal to 3. 1/2 times 2y is y minus y equals 3. Okay. Now this is where you can find out which one you have. You combine these two, y minus y is just 0. So you end up with 3 equals 3, which in this case is true. Okay. Now whenever all of your variables disappear and you're left with a true statement, then you know you have an infinite number of solutions. So that's when you know it's dependent. So when all variables disappear, and you are left with now the true solution, that's the important part. True solution then the two equations are equivalent. And there are infinite solutions. Uh-oh. Straighten that up a little bit. Okay, so infinite solutions just mean you have a dependent system. Yep. Okay. Now another way to look at it is let's say if we picked either one of those equations. Let's say x equals 6 plus 2y. So if we subtract 2y on both sides, it gives you x minus 2y equals 6. So what if we divide each of those terms by 2 or multiply them by 1/2? Oops. Okay, so if we multiply each one of those by 1/2, that's 1/2 times x minus, let's say 1/2 times 2. It was 1/2 times 6. So we just multiplied each one of those terms by 1/2. We'll bring that up some.
Where did you come up with the 1/2?
Well, with that one, because really the only reason I did that is because I'm going to turn this equation into that one. So really I just wanted to get the y by itself,
Okay.
since that was in the first one. Okay, so you have 1/2 x. 1/2 times 2 is just 1, so minus y equals 3, which, if you notice, is our first equation. So they're the exact same equation, just written differently. So if you graph both of them, they would just be right on top of each other. All right, so any questions on that one? All right. Leave that up for a few more seconds. Alright, so we're going to learn one more method for solving a system. That's the elimination method. Or sometimes they'll call it the addition method. Kind of depends on which book you're using. I believe here they call it elimination. Okay. Now with the elimination method, you want to kind of follow a few steps. It's not as direct as the substitution method. Okay. So the first thing you want to do is you want to write it in standard form. It just means you want to bring all the variables over to one side. So write each equation in standard form. So ax plus by equals c. That just means that a, b, and c are just any number at all. Clean that up some. Now, you won't always need the second step, but there are some instances where you will need it. So, if necessary, multiply one or both equations. Uh-oh. By a non-zero number. You can't just multiply them by 0. So that at least one of the coefficients, they have opposite signs, but they match up. Of a chosen variable are opposites. Okay, which is just another way of saying same number, different sign. Now your third step, you just want to add both the equations. You want to add the x terms together and the y terms together. Okay. Now if you did step number 2 right, one of those variables should disappear. So now you want to solve for the variable that remains, I'll say, instead of is left. Okay. Now your fifth step is, now you're going to get that variable and plug it in to solve for the other one. By plugging in the answer from step 4. And your last step is to check it if you want to. Like I said, that's optional. Okay, so let's say, for example, you want to solve the system by elimination. Okay, and let's say that system is negative 2x plus y equals 2, and negative x plus 3y equals negative 4. Okay. Now remember, your first step is to write it in standard form, which means all your variables are on one side. Okay. This was already in standard form, so you can skip step 1. Both are already in standard form. Okay, so you don't have to worry about that step on this one. Okay, now your second step, you want to have it to where if you add them together, one of those would disappear. So if you add negative 2x and negative x together, it wouldn't disappear. If you add y and 3y together, it wouldn't disappear. So you have to maneuver it somehow to where if you add them together, one of those would disappear. Okay? So you can pick either the x or the y. It doesn't matter which one you pick first. It's completely up to you. I'll pick the y, and I'll multiply all of those terms, by negative 3. Because if I multiply everything by negative 3, then negative 3y plus 3y, that would disappear. Now, if I chose this one, and I multiply each of these terms by negative 2, then that would give me negative 2x, and that would make that positive 2x. So when I add them together, it would disappear. So you can pick either one, and you still get the right answer. And I'll call this equation 1 and equation 2, so I don't have to keep rewriting it. And instead of 1 and 2, I'll write actual letters. So equation 1 and equation 2. Okay, so multiply each term in equation 1 by negative 3 to get rid of the y variable. Like I said, you could have picked the x if you wanted to. It doesn't really matter. Oh, that's going to shut off in about 30 seconds.